I'm at Morrow Mountain State Park, which I always call Mount Morrow, but it's actually Morrow Mountain. And we are in the eastern Piedmont, so from Davidson, it's about an hour, almost due east. It's probably not that far of a drive, really. There's just not really good roads there, so a lot of back roads to get here. So this is a decent drive. It's August. It should be 1,000 degrees outside, but it's a pretty nice day. Kind of mid-80s, probably down in the Piedmont, and something more like 82, 81 up here. So there's just enough people here. Class starts tomorrow for you guys. Local schools have already started for K through 12, and class starts for tomorrow for you guys. So I've come here. This is the eastern part of the Piedmont. We've crossed into what geologists might call the inner Piedmont. We've left that and we've crossed over into the Carolina Slate Belt, which is slightly lower grade metamorphism overall. But I came here to see something that we see in both parts of the Piedmont, which is a monadnock. And we can't see a monadnock in this photo because we're on the monadnock, right? So we're looking out into the Piedmont, and it's very flat out there, and yet we're really looking down on it because we're on the top of a mountain here. And there's lots of these mountains. Mount Morrow is one. If you've been to Crowder's Mountain or King's Mountain, there are others, or Stone Mountain. There's a million Stone Mountains, but there's one about 45 minutes north of Davidson that's another one. It's kind of in the foothills of the Blue Ridge. And so there's lots of these things. So why do we get these mountains that sit above a landscape that is otherwise so flat? And that's kind of the big question here for today. And so let's just think about the Piedmont broadly. So the Piedmont's just been sitting out here. It's pretty flat. I mean, it's hilly. It's not as flat as the coastal plain. It's pretty hilly. But in the grand scheme of things, when you look over my shoulder here, it's really quite flat. And so what are the geomorphic processes or the physical geography that is going to drive evolution here? And the answer to that question is there's just not a ton. There's not really enough topography for gravity to drive this. And without things that we get further in the north like glaciers, it's really just been sitting here for probably at least 2 million years, and maybe much, much longer than that. Now there's just enough topography in places to drive streams, and those streams do a fair amount of work. But for the majority of the Piedmont, the main process that's going on is just chemical weathering. So you just take some landscape and you leave it out in the sun for 2 or 3 million years, or maybe much longer, and it's really going to drive all the processes here. Is just like the rain and the weather, and that's the origin of the famous red clay that we get here in the Piedmont. We're going to talk a fair amount, or maybe we've already talked by the time you've watched this, about soil erosion. So that red clay didn't form at the surface, it formed in the subsurface, but it's been brought to the surface through erosion. And all of that is just the process of having a very, very old landscape just sit and kind of, rot, for lack of a better term. So what's the story with these mountains? Why do we get these mountains? These mountains are called monadnocks, named after a famous mountain in the Northeast where the idea was kind of conceptualized. And the idea is that there's something slightly different about the chemistry of the rocks here. And that difference allows it to not weather quite as quickly. So it's not that it was forced up in the same way we think of mountains. It's that when everything else eroded away, these things were just slightly more resistant. And that might just be that they're 5% more resistant. That might be that they're 2% more resistant. Maybe given the amount of time, these things are just 1% more resistant, and it just takes forever. So it's hard to say. I've got some people walking by here, so you may hear some stuff in the background. Crowder's Mountain is a really obvious one. It has a little patch of a mineral called kyanite sitting on the top, and that kyanite is enough to really protect the rest of the mountain and kind of drive it up through the surface as erosion happens to everything else. Here it's a little more nuanced. So we have a metamorphic rock called rhyodacite. It's a metamorphic rock of what is otherwise an igneous rock, and that is driving just a little bit of extra hardening of the rocks here. In fact, archaeological evidence suggests that Native Americans in the area were regularly visiting their own quarries around Mount Morrow as early as maybe 12,000 years ago to make tools, because the rocks were so much harder than the base rocks that we find elsewhere, especially if they were generally living out in the Piedmont, where at the surface you get a lot of red clay that's kind of rotting. So maybe the only source of hard rock that wasn't quartz in the area and quartz can be hard to work because it's so hard, was around the base of Mount Morrow, or Morrow Mountain, I should say. And so people came here to make those tools. We're also in a unique spot because we're on the edge of the Uares, and so the Uares, you will often read that they're volcanic in origin, and that's not really true. They're volcanic in origin in the same way that Yosemite is volcanic in origin, which means that the rocks that were underground were probably feeding volcanoes, but those volcanoes were kind of up in the sky, today's sky, and have well since eroded. And so this is kind of the feeder system. And so I'm gonna walk around a little bit. What's behind me now is not the Uares, that's looking the other direction. That's looking back towards the inner Piedmont. But we're gonna walk around the top here. So we're parked at a parking lot at the top, which is why there's a whole bunch of people around. We're gonna walk around a little bit. I'm gonna show you the view, the other direction out towards the Uares where there's a little more hills. None of it's really high enough to get up and out of the Piedmont, at least in terms of temperature. But we're at least gonna walk around. It's very beautiful towards the Uares. That's a national forest that way, so there's not very much development. I mean, there's not a ton of development in this part of the Piedmont. It's quite remote here, as you can see behind me. But the other way is even more beautiful. So we'll walk that way and I'll show you. Yeah, I didn't just come here to take these videos. I mean, I did, but I used this as an excuse because I'm gonna ride my bike too. I'm gonna go down to the base of Mount Morrow. It's about 500 or 600 feet down to the bottom. And then I'm gonna turn around, I'm gonna ride back up, and then I'm gonna ride down a different fork, and I'm gonna ride back up that way too. And we're gonna do that a few times. So I'm gonna do a little bit of recreating, so I kind of get 2 for 1 here. But yeah, let's look around a little bit. So this is looking towards the Uares, and they're small mountains, especially compared to what we'll look at in the Blue Ridge, but there's still some decent hills out that way. And that's a big volcanic province. And it's a good time to also talk about drainages. So the drainage divide in Davidson is the big drainage divide. It runs right under 115. So basically everything to the west of 115 drains into the Catawba River and goes into Lake Norman. And everything east of 115 goes into the Yadkin-Pedy system. And this is the Yadkin River over there that you can see. And it's dammed almost as much as the Catawba is. So that water you can see is Baden Lake. And then the dam is kind of behind these trees off to the right here. And then immediately below Baden Lake is Lake Tillery, which is another lake with another dam. So plenty of damming here, but it's still a beautiful spot. And you can see the way that these individual little mounds almost rise out of the Piedmont. And those are all due to, you know, minor changes in drainages, but really the underlying thing is hardness of rock, especially resistance to chemical weathering within those rocks. I've been looking around to see if I could find a rock somewhere. I haven't found any yet, but we'll poke around a little more. I'll find something. So it's gotten a little more interesting. I rode down and rode back up. I'm fogged up a little bit. And then about 100 yards from the top, it started raining again. So I figured I'd take a break, get a little water, and show you guys what it looks like, because it's pretty cool out there with the haze. I don't know if this is gonna last very long. I'm happy either way. It's cooling it down a little bit, but then the descents are gonna be tricky on the wet pavement, so we'll see. I thought I'd show you since it's kind of pretty. I've been looking at the rocks on the way down. They are different than anything I've seen in this area. They're very tight textured. They look almost like a really highly metamorphosed marble, which wouldn't actually be very resistant. But I think that's just the texture of them. I think they're a volcanic rock that's been metamorphosed. So there's not a lot of good places to look at them. We'll see, maybe I'll find somewhere. See you in a few. We're all the way down here at Lake Tillery with some storm clouds on the horizon. Although the ground's dry down here, so I don't really understand exactly where it's raining and where it's not. Clearly there's some clouds getting pushed up on the top, and that's why it's raining up there. Dry down here, but storm clouds in the distance. But this is Lake Tillery, so this is part of the Yadkin-Pedy system. Looking a little bit murky today, probably all the rain we've had recently. So cars back at the top, at least one more lap, maybe 2. Headed back up there. All right, so I took a couple laps on my bike, down to the bottom, up to the top. Then that's when I talked to you in the rain. Rain let up a little bit, headed back to the bottom, then the sun came back out, it got hot and humid. Anyway, I was gonna start a 3rd lap, and then I got a flat tire about 100 yards from my car. I figured that was a pretty good sign. It was time to call it a day. So I'm just kind of wrapping things up here. There's not a ton of rock outcrops here, although I will say there's not a lot of red soil either, which tells you that the minerals here aren't breaking down into those smaller red clay minerals, those iron oxides we're used to down in the heart of the Piedmont. I did pull over at a couple boulders here, so let's take a look. That one's sort of interesting. This one's more interesting because it's got a fresh face on it, and you can really see the texture here. And it's got this texture that kind of looks really solid to me, and it also flakes. I'm going to zoom in here. You can see how it kind of has this white flaky texture to it, and that's exactly what a lot of the arrowheads you see look like, have that flakiness to them, or points as they're called. So I get why this stuff might be hard enough for use for Native Americans, and I also get why this stuff might be hard enough. I mean, having not tested it or done any chemical treatments to it or anything, I could see why it might be hard enough to create an entire mountain out of. But the other ingredient there, right, is time. Like, there's lots of places where the bedrock is harder than other places. That doesn't just like inherently mean that one day there's a huge mountain there. You need time for everything else to wear away. And we use this word exhumation. The mountain isn't really like created or pushed up, it's exhumed. It was underneath all to begin with. And so it's everything else eroded away and weathered. We exhume this mountain out of the middle that kind of grows. So this is the rock that does it, apparently. Cool, so that's it for today. Thank y'all. Talk to you soon.